Hello and welcome back to part 3 of the Cybiko Repair-A-Thon series. In the recap, the first video we took a look at the hardware and repaired battery damage for all 4 units. This unit is powering on and booting, and the remaining 3 units all have black screens. And in the second part of the video, we took a look at the serial console using the serial connection cable and the libretto to try and get some information about the file system of the Cybiko and find if there was a way to go ahead and force an update, because it just seems like the flash, after the serial investigation, it just seems like the flash is corrupted on these 3 units. So I actually had an idea, and we'll take a look at the schematics here in just a moment. But one of the things you notice on the bottom of the Cybiko is they all have this connector port. I'll try and get a better view of that. So this is suspiciously and mechanically the same as PCMCIA. So I had a thought is if we take one of these kind of passive card adapters, and on the inside this is just a regular PCMCIA to compact flash adapter, and there's nothing electronic on the inside of this card. The only thing that it does is adapt the interface of PCMCIA to the 50-pin interface of the compact flash card. And that could be very important because it seems like we may be able to get to some of the signals for the flash chip over this connector. So I went ahead and opened one of these up. And here we have it right here. So this is just that same, this is the same thing on the inside. So all this is doing is taking the pins from the PCMCIA connector over here and adapting them to the pins of the compact flash card. So, and this little board comes out of this piece. And my thought was that we should be able to use just by soldering some wires onto these pins here of this connector and potentially breaking out our EEPROM reader to get a dump of the flash of the working unit and use that to repair the flash of the broken units. So let's take a look at the data sheet and see if we can understand, well, why this even makes sense. So be right back. Okay, so here I've actually found the Cybiko schematics. This was right from the FCC website, so that is pretty cool. So here they have labeled the board layout, and hopefully they've labeled and numbered all of the major components. And so that's the back side, and here we have the front side where the LCD and the keyboard are located. And then hopefully they've kind of provided a little bit of a block diagram. I'm not sure if this means they were intending on some of these things to be separate modules. But here we can kind of see some of the basic connections between major interfaces. So the RF module here, and then the keyboard here. And here we have the charging circuit, helpfully laid out. And then we get into the meat of it, and here we can see we have the diagram for basically the entire machine here on this page. On the next page they have the keyboard layout. So here's the keyboard matrix, address lines, data lines. And then here is the LCD connection. So this is also hooked up to the data bus, and then we also have some of the other components that are on the schematic. It looks like here is the voltage regulator for the input from the batteries, and this is what regulates the 3.3 volts for the main, for the machine, the CPU, the RAM, and then they have a separate regulator that provides, and I'm not really sure what this is configured for, I'm sure we could look this up on the data sheet, but this provides a separate power rail for the LCD itself, and so that probably helps with not only whatever voltage the LCD needs, but make sure that accesses to the CPU and other devices that are on the 3.3 volt rail aren't causing graphical glitches or dimming of the screen. So if we go back up, and I've started to make a good bit of sense of this schematic overall, is that here we have the main SRAM chip, 256K or 512K of SRAM, depending on the model. There's a little bit of a difference. So on some of the models it has two chips side by side, but this schematic only has the one. But here we can see it's connected to all of the address lines except for A19 and the upper 7 data bits, and then the other data bits, it seems like it has two 8-bit data buses, and you can configure them to either be in 16-bit mode or 8-bit mode per the schematic of this CPU. So it looks like they have it configured as two separate 8-bit data buses. The main purpose of the RW data bus here seems to be for the keyboard, as that is where the majority of those connections go, with the data bus being connected to the LCD controller and also to the SRAM. And then here we have two flash chips shown, and these are both serial flashes, and I'm not sure why they have two here in the schematic. And then here we have that 4 megabit flash chip, 512 kilobytes. And then we have the same data sheet for the 16 megabit or 4 megabyte flash chip. So I'm not sure if they were planning on offering two different models, but either way, on the actual units, we have this 4 megabit 512K serial flash chip. So I was looking at the schematic and I noticed that all of the signals that come off of the flash chip, they are directly connected here to the CPU. Most of the signals are right here and here. And then all of those signals are actually present here on this PCMCIA connector. And this is not an exact match of the PCMCIA pinout, but it is very close. So I don't think you would ever be able to use any existing PCMCIA cards, but we can certainly use the mechanical connector here to get some of these signals, because the traces are very, very small, and while there are a lot of test points available on the board, I couldn't find any test points that were hooked up to the signals here of this serial flash. So what I've started to do is map out the pinouts of this connector, and so I've taken the pins here for the flash that are relevant. The interesting thing is that although this is a TSOP package and it has a total of 28 pins, all of these on this side are no connection, and then almost half on this side are no connection. So there's actually only about 7 or 8 signals that we actually need for this package. So it's interesting that they have so many pins and so few of them are actually connected. So if we go back to the schematic, here we can see one thing right off the bat is that this write protect is permanently connected to the 3.3 volts. And so I wonder if that has something to do with the battery damage, is that potentially the unit was trying to boot up and it's written some bad data back to the flash chips, and now they're just unreadable by the Cybiko operating system. So we're going to try and connect up to this PCMCIA connector to get access to our serial data flash signals. Okay, so here I have the little PCMCIA to compact flash adapter PCB. The first thing I want to do is I think I'm just going to go ahead and remove this compact flash connector. I don't know if we can save it, but I think it will be better if we can just go ahead and remove it. That'll make sure that there's no clearance issues with the wires coming out of the socket. So let's go ahead and heat up the hot air gun. Okay, so the hot air gun is all warmed up, and let's go ahead and try and heat these pins. And we'll probably have to do this on both sides. Get this nice and hot. See the solder starting to melt. Okay, let's see if we can slide this off. No, it's almost coming off. I just need something to weigh down this other side. Okay, so I'm just going to use something to weigh down this board a bit. That way I can apply a little bit of pressure on the side here. So let's go ahead and heat this back up. Okay, it's starting to move a little bit. Okay. There we go. All right. Okay, so soldering iron's all heated up. So I think the first thing we'll go ahead and do is do a little bit of cleanup on these pins and just make sure that there's no bridged connections. This is not the world's best solder braid. Okay, so instead of using the solder braid, I think I'll just go with this standard kind of wiping trick. Just want to clean these up and make sure that there's no bridges between these pins. And then we'll do the same thing on this other side. Okay, that looks pretty good. So, and we actually were able to salvage this compact flash connector, so this might come in handy for another future project. So we'll just put this aside. Okay, so this next part, I've taken these little DuPont style connectors here, and I am going to, and I've already cut off one side and pre-soldered these sides here, and we're going to attach those to our PCMCIA connector. And it actually looks like most of the signals that we need are on the other side, except for one or a couple on this side. So let's go ahead and start with that. So one of the first signals that we need is the serial clock, or SCK signal. So I'm just going to pick one of our colors. I think we'll reserve the red and the brown wire as our ground and VCC, and then we'll use these other colors for our SPI signals. So I'm just going to go ahead and start with this gray wire, and we'll go ahead and connect that up. So yeah, it actually looks like all of the signals that we need are on the other side. So we'll go ahead and start connecting that. And just kind of go in order. It looks like for sure we need ground, and for sure we need the VCC, although we might not need the VCC signal. So we'll go ahead and just connect up our ground. And we know that the grounds are the 4 pins, or the 2 pins on either side of this connector on the outside. So this one's ground over here, and this one's ground all the way over here. And we'll go ahead and add just a little bit of solder to our board. Just like so. And then we will go ahead and attach our wire. And for that, we'll use this brown one. So we'll go ahead and attach our brown wire. so. And we will go ahead and attach our red wire for VCC to this VCC line. So go ahead and add a little bit of solder here. And attach our VCC wire. Actually, it looks like this could use a little bit more tinning. Yeah, that'll make that way easier to solder. Okay, let's try that again. So we'll go ahead and attach our VCC wire. Like so. Okay, just make sure that those are well connected. All right. So now we can move on to some of our other signals, and we'll have to count. Looks like one of the first ones we need is on pin 43, and that's our SCK signal. So we'll go 35, 36, 37, 38, 39, 40, 41, 42, 43, and we'll just go ahead and add a little bit of solder so we can easily identify that one. Okay. And for that, I'll just go ahead and use this gray wire. So let's go ahead and attach that. Okay, this seems good enough. Okay, so and the next wire we need is actually right next to that, and that is our chip select. So we'll use our white wire for that. And we'll get in here on the side and add a little bit of solder to the pad. And then we will add our wire. This is a little bit close for this gauge of wire. Okay, and I think I'll move this one just a little bit so that it's more out of the way. Man, it is not easy to solder on camera, let me tell you. Camera is right in the way what I'm trying to do. Let's add a little bit more tin on that pin. Okay, let's give that another shot. Okay, I think that'll be just fine. All right, so the next wire that we need is on pin 58. So that'll probably be easier to count from this side. Although we know our VCC here is on pin 51, so we'll count from there. So 52, 3, 4, 5, 6, 7, 8. So we're going to apply some solder there. And just to double check, we'll count from this other side. So 67, 6, 5, 4, 3, 2, 1, 0, 59, 58. So pin 58 is a reset signal. Okay, and we'll go ahead and attach our purple wire. And the next one we need is on 59, so right next to it. So we'll go ahead and tin our pad and just a little bit of solder. And we'll grab our orange wire. And this is the serial data out coming from the flash chip, I believe. So we'll go ahead and get this wire connected. Perfect. Okay, next we need pins 60 and 61. So I believe that means, okay, it looks like we didn't quite go in order. Okay, so 59, 60, and 61. So those are all right next to each other. 58, 59, 60, 61. So for pin 60, this appears to be a ready status of the chip. And we'll go ahead and connect our blue wire. Perfect. And lastly, we'll go ahead and connect number 61, which is our serial data in wire. And there we go. Perfect. Okay, so let's take a look at this and just make sure we've connected all of these signals properly. So if we start back at pin 35 here, and I almost think there's a bridge between these two, although we'll check this with the multimeter just to make sure. So here we have 35. So we want to make sure that on pins 43 and 44 are connected. So 35, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So pins number 43 and 44 connected here. We know we have pin 51 here, which is our VCC signal. And then we have this group of pins here. So we'll just count from here. So 51, 2, 3, 4, 5, 6, 7, 8. So 58, 59, 60, and 61 are connected. And then we have our ground. So this looks correct. Okay, so I think we'll go ahead and check this. I have the oscilloscope here in beep. So we'll just make sure that there's no bridges between these wires. So this looks fine here. And make sure that there's not a connection between these on the either side. So that is fine, and we'll check these. Nope, that looks good. Okay. Okay, so it's been a couple of days and I've been trying to read the flash of these Cybikos using this adapter. I can't get it to work on any of these units, and I have tried the venerable 866 TL8662 Plus EPROM programmer and reader. This doesn't seem to work. There's not a profile for the specific type of SPI Flash, but I did find the datasheet for the 8-pin version and using this adapter here. But it just does not want to read at all. I get back a complete blank, and the pin detect has a number of issues with the pins. And I've also tried using a Raspberry Pi and the Flash ROM library. But this also has the same problem, is that it just cannot detect the model of the flash chip, and thus it just cannot read it or write to it. And I think that has to do with a number of things, one of which is that either by turning on the Cybiko or supplying the VCC voltage over this adapter. It is wired up to the CPU and to some of the other components, and I want to say that either the serial clock or some of those other status lines are just being held in a weird state, or the clock rates don't match, and thus it just cannot talk to this SPI flash using this adapter alone. So I wanted to kind of go over some differences that I've discovered about the various units here, and we have them in the same order. So this is the original launch unit, and this is another launch unit. These two both have the soft power on, so these two have a physical power switch, and these two turn on as soon as you put in the batteries, and you can turn it on and off using the escape key. So what I've noticed is that while they all have the same exact flash chip, they have a fairly different arrangement of these other chips here to the side, and what I originally thought was just the SRAM on all of these actually turns out to be on this one. This is a 512K SRAM chip, just this one chip. And then in the slightly revised but also launch model, still with the physical power switch, it has two 256 kilobyte SRAM chips. And then these two are quite a bit different. It looks like it has a single 256 kilobyte SRAM chip. And then this other chip is a parallel flash. So this is actually hooked up to the same address and data lines as the SRAM, so on a traditional address and data bus, whereas it still has this separate 512 kilobyte flash chip between all of the models. So what I think that ultimately means is that when these are booting, it's reserving part of the SRAM address space in these to hold the actual, it copies the operating system, the .boot file out of flash and into RAM and executes it. And then the remainder of this chip is just used as general file storage, so uploading apps and other programs. And that kind of goes for all of these, except these actually contain the operating system directly in this flash chip. And I guess the theory is there that if the original units were just copying that file into SRAM and then executing it, that they could achieve the same effect by just having a parallel flash hooked up to the same address space that this I'm not sure if this is upper or lower, but hooked up to the same address space as one of these other SRAM chips. So it would just execute the operating system directly out of here. Now, I also gotta wonder if that means that there is more space left over, because the operating system generally doesn't take up that much space. So I wonder if they included any of the other files there as well. But in reality, you get about 80 to 90 kilobytes of additional space in your program flash area, just because now the operating system is contained here. So I think that kind of wraps up some of the differences here. I'm still not sure that even though these three units all seem to have the same black screen issue, I'm just at this point not entirely convinced that they all have the same problem. There could be a number of things preventing them from getting to the point where they're able to copy and run the, either this one will copy and run the boot file out of File Flash, or these two will execute the operating system out of this flash chip here. So we'll do a little bit more checking and be right back. Okay, so I thought it would be interesting to take a look at the 1 meg expansion card for the Cybiko, which comes in this little package here. So evidently on board, in addition to having a megabyte of expansion memory, this also has an additional 256K of SRAM. But to achieve the 1 megabyte of flash, it looks like they've used two 512 kilobyte flash chips, again, SPI Flash chips, the exact same ones that are in the actual Cybikos themselves. So I thought it would be interesting to open this up, take a look. I did find what appears to be a schematic for this particular card. So I thought if we could take our bit of compact flash connector that we took off of our adapter board previously, is that potentially we can try and wire this up to our SPI reader and see if we can actually read the contents of that SPI chip, just to make sure that there's not an issue with the particular arrangement that it is on the Cybiko. And then what I thought we could do is potentially remove one of the flash chips from the Cybiko, if we get that far, and see if we can wire this up as a stand-in. I just don't have any SPI Flash chips hanging around, so I think this may be our best bet. So let's start taking a look inside. Okay, so let's take our card and we'll try and pry this open as carefully as possible. And I'm not really sure where to start because there's no screws or obvious clips. Although this kind of appears to be a clip here, but the plastic doesn't appear to have any sort of give to it. So if we take our small tool, if we can get in on these edges. No, it just... oh, it doesn't feel right. I'm not really sure that this thing can be opened. There's a small gap over here. So the tool does go in. I don't just want to use brute force on this. I don't want to hurt the PCB inside. Seems like if we want this open, we'll probably have to pry this metal. Okay. Oh, so maybe that's just glued down. It is separating. Okay. So we'll just go slow. And okay. Okay, it's starting to separate. Yeah, it's just a lot of adhesive, like adhesive tape holding that down. And some sort of a shield. Okay, I wonder if we can just pull this off now. Okay. Right. Okay, so that's one side removed. So now we can kind of see a little bit inside, but this looks like the bottom of the PCB. So there's really not a whole lot to show here, but let's get some of this adhesive off. So it looks like we'll have to do the same thing on the other side. So we'll get our tool underneath. Find a spot where we can even get underneath it. There we go. Nope. Okay, yeah, so it's lifting off in the same way. So it just has this adhesive tape, it seems like. And keep carefully going around the side. I don't want to damage any of the chips or the circuit board inside. And I could not find any pictures of the inside of this card. So this might be the first time we've ever seen one of these on video. And already this is a little bit different than I was expecting. Okay. So here is our SPI Flash chip. And here is our 256K of SRAM, but interestingly, it does not have another SRAM or flash chip. So this one, oh, this is okay. This is a different model number. So this is the 081A AT45DB 081A. So this is actually a 512. No. This is the 8 megabit flash chip. So this is the 1 megabyte SPI flash. So this is not quite the same chip that we were expecting, and it's a good thing we opened this up because we may have been looking at the pins for this other flash chip and wondering why it wasn't working. So let's see if we can work out the connections here and attempt to hook up to this card. Okay, so here we have the little memory card, and I've marked pin 1 here on the connector, just so we have a reference, and I have the pinout up for the memory card expansion, and I've confirmed that all of the signals for both of these SPI flashes are connected in parallel, so they're mirrored over here, except for the 2 chip select lines, and the 1 chip select line that we need is all the way on pin 36 on this side of the connector all the way down here. So what I think we'll do is I have cut off one of the sides of our compact flash connector, and we're just going to connect it in like so. And for the chip select line that we need, we'll just pull one of these pins out and insert it manually into the connector over here. So let's get to soldering. Okay, so if we take our other adapter here as a reference and confirm that we're looking at both of these in the same orientation. So we know that pin 68 is all the way over here on this side, and that's our ground. So we'll go ahead and hook up that wire first. Turn this around to make this a little bit easier. And we will weigh it down with these pair of pliers. And I already have pre-tinned another set of these DuPont cables. And I'm just realizing there's not a brown one. So hold on, let's fix that. Okay, so here is our brown connector, and I was also missing the orange one had walked away, and the brown one apparently I had forgot about entirely. So we'll move this off to the side, and we'll go ahead and weigh this down. And let's go ahead and hook up our ground wire to pin 68 on the PCMCIA, and we'll just have to make sure that we remember that we're a few short on this side. So go ahead and apply a little bit of fresh solder. And connect this one up, get that a little bit straighter. Okay, so that'll be our ground wire. And just realizing that's not a very great view, let's bring that up a bit. So yeah, here's our ground wire. It looks like on pin number 60, we have a reset signal. So it doesn't appear that this is strictly necessary, but it was connected on our other adapter. So we'll just mirror that same kind of configuration. So let's move this and we will count 68, 7, 6, 5, 4, 3, 2, 1, 0. Let's apply a little bit of fresh solder. And we'll hook up our blue wire, and we just need to be very close here. Okay. And next we have on pin 58, that'll be our purple wire for the reset signal. Okay, so yeah, blue was for the ready status, and 58, our purple wire here, will be our reset signal. So that is just, so 60, 59, 58. Apply a little bit of fresh solder. And just ease our cable onto there. All right. And then on pin 57, that will be our serial data in, and that is our green wire. So we'll start having to get pretty close here. So we'll go ahead and tin this wire, hook up our green wire. And yeah, those are pretty close. I'm going to clean this one up a little bit. Okay, that's better. And then on pin 56, we have our orange wire, and that is our serial data out. So that is right next to that. Okay. And then next to that is our gray wire, which is our serial clock. Go ahead and add some fresh solder here.
Perfect.
Okay, so our white wire, that is our chip select line, and that connects all the way over here on pin 36. So the last one that we need here is our VCC. So if we know that our gray wire was 55, we just need to count over. So 55, 4, 3, 2, 1. And we'll add some fresh solder. And we'll just make sure. So 55, 4, 3, 2, 1. It's quite fiddly. Okay. Perfect. And for the last wire, I'm just going to go ahead and connect this up to one of these other random pins, and we'll just pull that out once the wire is soldered on. So I'm going to give some fresh solder here and connect our white wire for our chip select. Okay. All right, so we have here all of our wires soldered up. So I'm going to go ahead and just pull, I guess we can go ahead and take this off, and then we'll just pull this wire out. It should just, okay, there we go. And so now we should be able to plug this back in like so. And just make sure that we don't have any bridges. And since this is pin 36, it's going to be on the top side, and the first pin here, 35, is our ground, so we'll plug it into the second pin here on this side. And that should be our interface. So there you go. Let's see if we can get some life out of this. Okay, so yeah, this did not work as I had hoped. Tried reading this with both the 866 programmer here and also the Raspberry Pi. Same error from the Raspberry Pi using Flash ROM is that no flash was detected. And with the 866, I was actually getting some inconsistent results, and it seemed like they had recommended adding a capacitor here on the ground, a 2.2 UF capacitor here between power and ground, and 100 UF between serial out and ground. I didn't have any 100 picofarad capacitors, so I just used two 47 here in parallel. And yeah, it almost seemed like we would get some reads using this programmer, but I was not able to verify that. It just did not read consistently, but I'll get a better shot of these capacitors here connected to between pins 2 and 4 here, and then just an extra capacitor between power and ground. So I'm not really sure where to go from here. I did end up copying a application to this card using the Cybiko so that I would have some data to read, because when I read it the first time, I was getting back just all FF. So I was hoping that meaning that it was working, just blank. But after copying a game and an application to this card, I'm still not seeing any data. And trying to read this and verify this multiple times gives, hundreds of different read errors. So I'm not really sure if that's because of the length of these cables. But yeah, so stay tuned for the next part. If anybody has any ideas on what may be going wrong with my setup, both to be able to read the internal SPI flash of the Cybiko using this adapter, and using this adapter to read the SPI flash inside of the extra memory card. So stay tuned, and hopefully in the next part we'll be able to make some better progress. Till then, thanks for watching.